Good morning, class. To continue with our activity on alcohol dehydration, we have here two alcohol samples previously taken. Here we have a dilute alcohol solution, and here we placed in this beaker, we placed in a much higher concentration of alcohol solution. If you could notice, by the time we put copper sulfate, the dehydrating agent for alcohol, in the dilute alcohol solution, if you could notice, the copper sulfate added turned blue, absorbing the water therein. And if you could notice, it's almost dry, considering that probably there is a very less amount of alcohol in that solution. So the alcohol remaining in this beaker is quite very small in amount, if you could notice. While the rest of the copper sulfate added turned blue, and the liquid volume of the alcohol solution is now reduced to this little amount, considering that most of the water had been absorbed by the copper sulfate. While in a more concentrated alcohol solution, if you could notice, copper sulfate also turned blue, absorbing water. But if you could notice, there is still a substantial amount of alcohol left in this container, considering that this alcohol solution might have a much higher alcohol content than water. Again, the copper sulfate turned blue, absorbing the water from the solution, and the remaining alcohol, which is evidenced by this liquid here remaining in our beaker, is of much higher volume or quantity compared with the less concentrated alcohol solution, wherein the liquid left from the solution after adding copper sulfate is only this little, while most of the water had been reabsorbed by the copper sulfate. So that is all for our experiment on alcohol dehydration, as evidenced by how copper sulfate reabsorbed water from our two samples of alcohol. Again, a less or dilute alcohol solution, and the reaction in a much higher concentrated alcohol solution. That's all for now. Good morning.